Hello everyone, this is Namitaa Chandrashekhar from SEABORN, roll number 13. Today, I'll be giving a presentation for my Data Analytics Lab oral exam, guided by Professor Harshali Mani. Question number 1. Perform wrangling method, mean removal, scaling, normalization, and binarization operation for the given array. Now let us understand what data wrangling is. Data wrangling involves processing the data in various formats like merging, grouping, concatenation for the purpose of analyzing or getting them ready to be used with another set of data. And Python has inbuilt features to apply these wrangling methods to various data sets to achieve the analytical goal. Mean removal. So, mean removal in machine learning is a type of pre-processing technique which is used to remove the mean. Normalization. Normalization methods, approaches, and techniques are designed to specifically prevent data impact and prevent the loss of data. For example, where the original data is moderately good, normalization technique gently goes through the data to ensure that the raw data is not drastically affected. Scaling. Scaling is a type of pre-processing which is applied to independent variables or features of data. Now, why do we need to use the scaling? So, real world data set contains features that highly vary in magnitude and range, and normalization should be performed where the scale of these data sets is irrelevant or misleading. Binarization. Binarization is the process of transforming data features of any entity into vectors of binary numbers. For example, transforming an image grayscale from, let's say, 0 to 255 spectrum to 0 to 1 binary spectrum is called as binarization. Now, let's have a look at our code. Yes. So, over here, in the first step, we need to import all our libraries which will be used, such as NUMPY and yes. After that, after we import the libraries for this given array, we will be able to perform the mean, the binarization, so the binarized data, and normalization. This is the normalized data. Let's move forward. Question number 2. What is the process of data analysis? So, data analysis is basically a process um, for obtaining the raw data and subsequently converting it into information useful for decision making. And the terms data modeling and data analysis mean the same. So, following are the phases of data analysis process: data requirement specification, data collection, data processing, data cleaning, data analysis, and communication. So, data requirement specification. So, the data required for analysis is known as the data requirement specification. We need to provide all the required data for the analysis, and based on the requirement of those directing the analysis, the necessary data as inputs to the analysis is identified. Like, for example, the population of people, specific variables regarding the population, like the age and income of the population may be specified and obtained. Data collection. Data collection is a process of gathering information on targeted variables identified as data requirements. So the emphasis is on ensuring accurate and honest collection of data. So thus the data obtained may not be structured and may not contain irrelevant information, and hence the data is required to be subjected to data processing and data cleaning. So data processing. The data that is collected must be processed or organized for analysis. And This includes structuring the data as required for the relevant analysis tools. Like, for example, the data might have to be placed into rows and columns in a table within a spreadsheet or statistical application. Data cleaning. So the process and organized data may be incomplete, um, containing duplicates or errors, and so data cleaning removes or corrects these errors. Um, Likewise, the quantitative data methods can be used for outlier detection that would be subsequently excluded in analysis. Data analysis. So, data that is processed, organized, and cleaned would be ready for analysis. Um, Here, data visualization may also be used to examine the data in graphical format to obtain the additional insight regarding the messages within the data. Um, Statistical data models such as correlation, regression analysis can be used to identify the relations among the data variables. Um, yes, so that was data analysis and communication. The result of the data analysis are to be reported in a format as required by the users to support their decisions and take further action. So if and the feedback from the users might result in additional analysis. So if there is a negative feedback, it might be we might be able we might have to uh, do another analysis on it. And so the analyst can choose data visualization techniques such as tables and charts, which will help them in communicating the messages clearly and efficiently to the users. Um, yes. Question number 3. Differentiate and perform regression analysis for R squared and adjacent R squared analysis. Now, what is regression analysis? Regression analysis is a set of statistical methods used for the estimations between a dependent variable and one or more independent variable. So, it can be used to assess the strength of the relationship between variables and modeling the future relationship between them. Now, what is squared? Um, R squared is a statistical measure of how close the data are to the fitted regression line. It is also called as coefficient of determination, coefficient of multiple determination for multiple regression, and its formula is explain variation by total variation. Adjusted R squared. Uh, Adjusted R squared is a modified version of R squared that has been adjusted for the number of predictors in the model. And the formula for adjusted R square is 1 minus 1 minus R square into n minus 1 by n minus k minus 1, where R square is the R square of the model, n is the number of observations, and k is the number of predictor values. So let's have a look at the code. Yes, so this is the code that I made. So here to explain the R squared and adjusted R squared regression, I have taken an example of housing dataset of Boston City. So first we import and define all the libraries, PANDAS, PD, MATPLOLIB, .pyplot, SPLT, SEABORN, SNS, and NUMPY as NP. And then we load the dataset as follows, followed by the, just a second, yes, followed by the attributes which include the features, file name, and target. So here we have the attributes per capita crime rate by town. NOx is the nitric oxide concentration. CHAS is the Charles River dummy variable. So basically, this is everything we look for while buying a house. And all these attributes are given over here. And the number of instances that we have taken are 506. Yes. Uh, Yes, so here we are adding all the features, 506 instances and 14 columns. Yes, so these are all the 506 rows and 14 columns with the 14 features. So now we will plot the histograms to visualize data and to get a clear picture about attributes. So the first one is number of houses versus the house prices. Um, and over here we have again we have number of houses versus house prices, but here the graph is different. Um, then we have number of houses versus the average number of rooms, number of houses versus the index of accessibility to radial highways. Basically, these are all the features we look for while buying the house. And so for that, we have plotted these graphs. So basically, we first provide all the necessary information to our program, and then it gives us the result accordingly. Yes, number of houses versus accessibility to radial highways. Um, yes, so now correlation between features and their target variable. So over here, data.corr, which is the correlation, it gives us the correlation between these features and their price values. So here, as you can see, one is diagonally, one over here. All the values are 1, 1, 1, 1, 1 because that's how they are related with each other. And if you see the opposite ones, they are same. Um, yes. So then, yeah, so following is our heat map. So this heat maps basically is the same thing, but it gives us the colored uh, colored values or the attributes. Um, yes. So heat map, it contains the values representing various shades of same color, and it's different for every color. It shows us the feature versus the targeted value. This is our scatter plot. It's showing us the graph of nitric oxide pollution versus the distance from the employment center. So as you can see over here, the closer the distance, like the 2 miles, 4 miles, 6 miles, the closer the distance from their houses, more is the amount of nitric oxide pollution because people generally prefer to go closer to their houses. So, and over here, if you see 12 miles, so over here there is less amount of nitric oxide pollution. So that's what this scatter plot shows us. Yes, so this graph over here, it gives us the combined scatter plot and histogram of the nitric oxide generation versus distance from the employment center. So yes, over here, x underscore train. Here we are setting some values for the training model and some for testing model. So we need to train the model in order for it to understand the data set and give us an output. Now we come to the regression part. Yes, so this reg.fit, this is used to train the model on the training data set, and y underscore pred is an array that has all the predicted values for the testing data set. So now we find the slope in order to plot the regression graph. Reg.score tells us how well the model is training and learning and how well it is performing on the training data. And this reg.score, this shows us the score of its testing data prediction capability, how well the model is performing on testing data. And R square, yes, here comes our R square value. So R square or R square is used to find the error between the actual values and the predicted value. So the value of R square comes as 0.67 because that was asked for us to find. And here is our adjusted R square. So adjusted R square according to the formula, the value of adjusted R square comes as 0.66. So that's how we perform the regression analysis. Just a second. Yes, and this is our graph. Yes. So that completes our regression analysis. Let's move forward. Topic of your choice. So um, the topic that I have chosen is tools required for Python or data analysis. So exploratory data analysis or EDA is often used to uncover various patterns present in data and to draw conclusions from it. And EDA is a core part when it comes to developing a machine learning model. And this takes place through analysis and visualization of data, which will be fed to the machine learning model. And without proper insights and analysis of different patterns present in our data, you cannot go forward with creating your machine learning model. So the perfect pack for starting with EDA is a set of Python modules specially used for data analysis and visualization. These include Panda, NumPy, Matplotlib, and SEABORN. So let's have a look at them. Pandas. Yes, Pandas is a software library written for the Python programming languages for data manipulation and analysis. It helps in Pandas basically helps in manipulating the data in tables and series respectively. So once you start importing the data sets and work on them, you will notice how important Python actually is. So not necessary to know literally all the functions. Uh, sorry, all the functions present in the library, but we need like we it helps us in manipulating data a lot. And this is the declaration required for Python import pandas as PD. This is what we use, right? So NumPy is a library for Python programming language, adding support for large multidimensional arrays and matrices, along with a large collection of high-level mathematical functions to operate these arrays. So when it comes to using NumPy in your code, you can easily automate your data related to multidimensional arrays. NumPy helps a lot in deep learning where images are to be transformed in a specific manner in order to set the training and testing evaluation data. This is the declaration of NumPy. Import NumPy as NP. Matplotlib. Matplotlib is a collection of functions that make Matplotlib work like MATLAB. So we all know what MATLAB is. It is a it's a programming platform for numerical computing of data. And each pyplot function makes some changes to a figure, creates figures, plotting area, etc. So Matplotlib helps in plotting your data vividly in order to understand the patterns present in dataset. Like it is possible to draw conclusions of your data without visualizing it. So using Matplotlib, um, we try creating bar plots, histograms, scatter plots, as I had shown you in the previous code. All those are done because of Matplotlib, and it helps a lot when it comes to data modeling and machine learning. So this is the general declaration. Import matplotlib.pyplot as PLT. Let's move to the last one, SEABORN. SEABORN is a Python data visualization library based on Matplotlib. It's based on the previous one only. It gives a high-level interface for drawing attractive and informative statistical graphics. So, like I said, SEABORN is similar to Matplotlib. The only difference is that the former one has much like advanced parameters present in respective functions. So, like again, the main idea behind Seaborn and Matplotlib is to identify many patterns present in your raw data and to eliminate the unrequired data from your data set and to feed it to your model. And this helps in providing uh, improved accuracy and knowing the data more clearly. This is the declaration for SEABORN. Import SEABORN as SNS. So basically, PANDAS and NUMPY, both these libraries are used for manipulation of the data as well as uh, to get the brief view of the data quickly. So PANDAS, NUMPY, or any other tools can be integrated for visualization using MATPLOLIB and SEABORN libraries. Um, Data analysis is nothing without data. So, in order to get decent knowledge in this domain, the only key is to use these libraries together in our code. And this will help in understanding the required and necessary functions of modules and proper use of them in times of need. Thank you. That's all from my side.